Our design requirements were based on requirements given in the project description as well as our intuition of how the design would be used in the real world. The jack was to be designed for use in construction or farming, so we knew that chances of improper use were high. We needed the jack to support at least 2,000 pounds and lift at least 6 inches. We also discussed various ways the jack could be misused, such as having loads applied off-center or using the jack in compression rather than tension. We also wanted to try and minimize the weight and cost of the materials as much as possible. Our models came from equations used in the previous static analysis project, modified to work with the geometry we selected for each part. We then found parts in McMaster-Carr that would be close enough geometry-wise to what we designed or modeled them ourselves in SolidWorks. We decided to optimize our diagonal U-channel. To do that, we used a spreadsheet. In this area, we have a couple parameters that are fixed, and in this area, there's a couple parameters that we varied in order to meet the safety factors and to optimize for mass. So these columns here, they have equations for bearing, tear out, and axial forces, and then we have the safety factor associated with it. By varying these numbers, we came out with an optimized solution. And then because we decided to go with McMaster products, we found a couple that might work and then ran them through to see what the safety factors would be. And then we settled on one that had good safety factors. Once we finished our analysis, we put our CAD model of the jack into ANSYS in order to verify our calculations and see if there was anything we may have not considered. We tried to make the search process simple by using available resources, including McMaster-Carr stock parts and ideas from previously existing jack designs. We had no reason to reinvent the wheel. Using pre-existing parts would also help cut down manufacturing costs, since we wouldn't have to manufacture parts from scratch. One of the lessons learned was that you just have to start somewhere. Optimization and models can become very complicated and intertwined, and if you don't make an initial decision about some aspect of the design, you won't get anywhere. Another lesson learned was that it's better to have something that's good enough but not perfect instead of spending all your time trying to come up with the ultimate perfect design. Our design may not be the best, but it exists and will get the job done. Whereas if we had gone the original route of optimizing everything, we would still be stuck in the design phase of this project.